Okay, I understand some people are having some trouble with balancing chemical equations. So I thought I would at least show you how I did today's homework. Excuse me. And in the meantime, I did put up on the Google Classroom that I will be doing a live video stream help tomorrow through Zoom. So if anybody is struggling, I made it for 3 o'clock in the afternoon in hopes that people earlier will see the message if they're going in, and then they can attend that meeting if they want. And if any of you have never done a Zoom meeting before, it's like Skyping or like FaceTiming in real life person. So you'll be able to see my desk and you'll hear my voice, and you can mute yourselves and you can chime in when you have a question or don't understand what to do. So I want to do at least the homework from today, or the classwork I had you doing today. So we were on page 61 and there was two possible problems. One said to balance the equation for the reaction of sodium metal, which is sodium, with oxygen gas. And they told me that oxygen gas is O2. And it forms sodium oxide. So it forms Na2O. They gave me that information. Very first thing that I want to do, step one, is to write out the equation. And I'm putting a dash in front of every possible compound so that it is telling me how many of each of those pieces we're going to have. Step two asks me to write out or count the atoms. So this is where we're going to do reps. So I've got my reactants, my elements, and my products. So here, I look at it like a big old teepee. Okay, the elements are sodium and they're oxygen. So step two has me count them out. On the left-hand side, again, this is my reactants over here. Sodium comes as a single. How many total pieces of oxygen do I have? This subscript 2 is telling me that this basically is 2 pieces of oxygen stuck together to make one compound, or oxygen gas. So every time I have one of these, I'm looking at 2 pieces of oxygen every time. I want to do the same exact thing with the products. On the product side, for every time I have sodium oxide, I have 2 pieces of sodium and 1 piece of oxygen. So I have 2 pieces of sodium, I have 1 piece of oxygen. I'm now done with step 2. Step 3 tells me to use coefficients in order to balance. Now I like to use a different color pen. Again, if it's a blank line here, it's assumed 1. So showing nothing is the assumption of 1. When I'm looking at, I need them to be balanced on both sides. What goes in must come out. So I can clearly see here that I have only 1 piece of oxygen coming out, but 2 pieces going in. So I have to use a coefficient in order to get at least 2 pieces of oxygen to come out. Since it comes only one at a time, every time I use this compound, I get 1 piece of oxygen. I want there to be 2. So I'm going to ask for 2 of that entire compound. And when I do, that 2 means that I'm getting 2 groups of 2 for sodium. And I get 2 of my single pieces of oxygen. So 2 at 2 a pop is going to change the number of atoms of sodium to 4. And 2 times my oxygen means I get 2 pieces of oxygen. Since there's no subscript, again, it can be assumed that it is times 1. So it's just like in regular math or algebra. When I use a coefficient, I'm basically multiplying right through my whole thing. So that is the same thing as saying 2A and 2 pieces of B. So I have 2 pieces of 2 each of sodium. I have 2 pieces of 1 piece each of oxygen. So I'm going back to my equation. So now my oxygen is balanced. I have 2 in and 2 out. With my sodium, however, I now have 4 coming out, so I need to set it so that I have 4 coming in. On the reactant side, how can I get myself to have 4 pieces of sodium? Because what goes in must come out. So I can use the coefficient here of 4. 4 times this piece. This is one separate compound. So if I put in 4 pieces of sodium metal, that means that I am, on the reactant side, 4 pieces of sodium. There is nothing more to this compound, so I don't need to multiply this coefficient times anything else. So now I go to step 4. Look back and check. Sodium. Law of conservation of mass says what goes in must come out without any leftovers. So I've got 4 pieces going in, I've got 4 pieces going out. Check. Oxygen. I have 2 pieces going in, I have 2 pieces coming out. Check. So it's now totally balanced. The answer to the first one on page 61 is 2 sodium plus 1, or a blank, oxygen gas yields 2 of the sodium oxide. Okay? That's number 1. Let's try number 2. Problem number 2 said balancing chemical equations. Balance the equation for the reaction of tin, or SN, with chlorine gas, Cl2, and that it forms, or yields, tin chloride. And they give me the formula for that as well, SnCl2. So I want to put a space in front of everything, each of those compounds, in order to check it out. I want to do my reps. So in the middle, I'm putting my possible elements. Possible elements are tin and chlorine. Now I want to count out the number of atoms. On the left-hand side, or my reactant side, I only have 1 piece of tin. I also have 2 pieces of chlorine, because in order to create this compound of chlorine gas, there's 2 pieces of chlorine joined together in order to make that. On my product side, I have 1 solid compound. And in this 1 compound, for each time I have it, since there's no subscript next to tin, that must mean I have 1 piece coming out. But I do have this 2 subscript next to the chlorine, which means I have 2 pieces of chlorine. Number 3 says to use coefficients to balance the atoms. But I look through and I see that 1 came in and 1 came out on on tin. And I see that 2 came in and 2 came out of chlorine. I don't need to mess around with any of my coefficients. I want to leave this one alone. It clearly is already balanced. So my final balance, and again, I did step 4 already, I checked. So my final equation for this chemical equation to be balanced is 1, or a blank, Sn plus 1, or blank, Cl2 yields 1, or blank, SnCl2. Alrighty? Let me clear my paper and we'll move on to page 63. Okay, now page 63. Problem number 4 for math practice said to balance the following equations. And they gave me Fe2O3 plus C yields Fe plus CO2. Okay. So the very first step is to write out the equation. And I put this underline in front of each and every compound or unit. Okay. Step 2 wants me to count the atoms. When it comes to count, we need to count reps. So, our possible elements are going to go in the middle. And I think it's easiest just to move from left to right. So my very first element is an Fe. Next element I see is O. Next element that I see is carbon. And I get to the yield arrow. Again, the law of conservation of mass says that matter can't be created or destroyed. So everything that goes in needs to show up on the other side of my equation, must come out. So let's count the number of atoms that I have. On the reactant side, or the left-hand side, every time I have one piece of Fe2O3, it's as if somebody said, I'm going to put 2 pieces of that and 3 pieces of that in each and every unit. So by having a blank one, or one in other words, every single time I see this, I have 2 pieces of Fe going in. I also have 3 pieces of oxygen. In carbon, I only have 1 piece. Over here, it's a separate one. On my product side, Fe is single, it's by itself. So every time I have one, oops, I was about to write Fe again. I only have 1 piece every time. But when I look at this compound right here, carbon dioxide, it's the same thing as if somebody said, here's 1 piece of carbon and here's 2 pieces of oxygen. So this represents that every time. So if I have just one of these, I have 1 piece of carbon and I have 2 pieces of oxygen. Can we see how I came up with that? Okay, move over to step 3. Let's use our coefficients to balance these equations. Well, what comes in must be going out. So I think the trickiest one here is the fact that oxygen has 3 at a time going in and only 2 at a time going out. So even if I were to take 2 of these, I would then wind up with 4 oxygens. That doesn't work. So I need to figure out how to come up with the same number over here as I do over here. So maybe if I wound up making it so that 3 at a time, I got 6 going in, then I could wind up pulling 3 of these so I could have 6 going out. Let me show it to you instead. So if I said, let me bump this up, because if I do just 2, that's not going to help me. That would wind up giving me 2 carbons now and 4 oxygens. But 4 doesn't work because I have 3 going in. So I'm now going to need to increase the oxygens on the left-hand side. So let me set up, if I made a second compound over here. I want 2 of these units. Now I wind up having 1, 2, 3, 4 pieces of Fe, and I have 1, 2, 3, 4, 5, 6 pieces of oxygen. Let's go back over, because now since I have 6 pieces of oxygen going in, I need 6 pieces of oxygen coming out. So I'm going to change this coefficient, and I'm going to get a 3rd piece. So now I have CO2 3 times, 3 of those pieces. So now in total of carbon, I have 1, 2, 3 atoms of carbon. And I have 1, 2, 3, 4, 5, 6 pieces of oxygen. So right now my oxygen is finally balanced. 6 went in, 6 are coming out. Let's attack something else. Let's try the Fe. I have 4 pieces going in, but I only have 1 coming out. So what number do you think I should put here so that I wind up having 4 Fe atoms? If you guessed 4, you're right. Now I have 4 atoms going in. I have 4 atoms coming out. Oxygen, I have 6 going in, and I have 6 going out. But carbon, I have only 1 going in, but I have 3 going out. So I'm going to have to do something to this side so that I wind up having 3 atoms of carbon so it can balance. So what number do you think I should put there if I need 3 atoms of carbon in order to go into my reaction? I'm hoping you said 3, because that would change it. I move on to step 4. I look back and check. Fe, I have 4 in, I have 4 out. It's balanced. Law of conservation of mass confirmed. Oxygen, I have 6 going in, I have 6 coming out. It's confirmed. Carbon, 3 going in, 3 going out. Confirmed. So the final balanced equation for number 4 is this. It would be 2 Fe2O3 plus 3 carbon yields 4 Fe and 3 carbon dioxide. Make sense? Hopefully, eventually, this is going to click for some. But again, I do have a live feed happening tomorrow. So at 3 o'clock on Tuesday, in case we need to do this interactively together. Let's try number 5. Number 5 in the book gave me sulfur dioxide plus oxygen gas yields SO3. When I write my equation, I want to put a dash in front of each of my compounds. Moving on to step 2. Count the atoms. When it comes time to count, we want to do reps. Reactants, elements, and products. My possible elements. I have S coming in over here. I have oxygen. I have oxygen again. It's not a new element. And that's it. What goes in must come out. Stays the same. So now I need to count them. How many pieces are going in and how many pieces are coming out? Well, from this, it's the same thing as looking at one S, one O, and another O every time I look at one of these pieces. So that means that going in, I have just one S. But so far, I also have 2 atoms of oxygen. But I need to keep going because I'm not done with all my reactants. Every time I see that, it's the same thing as looking at a bundle of 2 O's together. So they're also going in. So I wind up having, in essence, 2 plus 2, which is 4 pieces or atoms of oxygen that go into this problem. On the product side, I need to count my atoms again. And SO3 is the same thing as calling it SOOO, except for they call it SO3. So every time I get a number in here, I have to take the whole bundle. So a single piece has only 1 S, but it has 3 oxygen. So I've got 1 reactant sulfur, 1 product sulfur. Well, that sounds great. But unfortunately, I've got 4 reactant oxygen and only 3 product oxygen. That's going to cause me a problem. So this is where I want to go to step 3 and use coefficients in order to balance my equation. So let's try first to get my number of oxygens up because I have 4 that went in. Let's see if I can get it up again. Well, if I add another piece, I have to do the full set. So I'm using the coefficient of 2 of them. So that means that I have 2 pieces of sulfur, and 1, 2, 3, 4, 5, 6. I have 6 pieces of oxygen. Another way to do it is, again, by multiplying through 2 times 1 or 2 times 3. 2 times 3 is 6. So now I have 6 pieces of oxygen coming out, but only 4 that go in. I still have a problem. I also see that I have 1 piece of sulfur that goes in, but 2 pieces of sulfur that go out. Doesn't matter which one we want to attack first. Let's go for the sulfur. With the sulfur, I have 2 now that have to come out. So I want to make it so that I have 2 that go in. The only piece here that has sulfur at all is this one. So I have my 1 piece because of that 1 unit. So I want to add a whole nother unit, giving the coefficient of 2. And I now would count out how many total I have in. I have 2 pieces of sulfur, and I have 1, 2, 3, 4 pieces of oxygen. Now 4 plus 2, because you can't forget those guys, is now 6. So I think I just accidentally fixed it. Sulfur. I'm moving on to step 4. I am checking. 2 pieces or 2 atoms of sulfur going in, 2 atoms of sulfur coming out. Confirmed with the law of conservation of matter. Oxygen. I have 6 total pieces that came in, and I have 6 total pieces that came out. That's confirmed. That means that this equation right here is balanced. When I say 2 SO2 plus blank or 1, O2 yields 2 SO3. I think we'll attack the classifying the chemical reactions. Maybe we'll try and hit that tomorrow. But at least for now, you can understand how I got through the homework from today. Again, if you're still having trouble, please be sure to tune in to our live Zoom meeting. See you guys then.